Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll be covering these titrations between an acid and a base. It's called an acid-base titration. I'll be doing a sulfuric acid and a sodium hydroxide titration. So just like any other acid-base titration, we'll need this apparatus. This is called a burette. So it reads from 0.0 cm cube. Well, at least you give it to one decimal place when you're in O-level, IGCSE or GCSE level. It runs all the way to 50.0 cm cube. It's got this tab at the bottom there. And there is also this specialized apparatus. This is called a pipette, P-I-P-E-T-T-E. This one is a 25 ml, meaning it's a 25 cm cube pipette. So the good thing about pipette is that it's quite accurate, but it can only measure a very fixed volume depending on the size of the pipette to begin with. So unlike burette, which can measure volume, they are not exact because it has got graduated lines that allow you to read the volume in between. A pipette can only read a fixed volume, although both are very accurate volumetric apparatus. Volumetric analysis means we are doing solution chemistry. We need it to be exact in order to do the kind of calculations in order to work out concentrations or the volume required for complete neutralization. This is a conical flask, so in reality, in exams, the stuff that you're given should be pretty cleaned, but if you're doing practical in school setting, you never know who was the last person to use your pipette, and therefore you have to rinse them with water. But in a real exam, typically your stuff is quite clean already, so you don't have to rinse them with anything. I rinse first with distilled water, but the most important thing about pipette is you must not let any distilled water remain in there. You have to rinse it with the solution that you're going to fill it in later on. And that is what you should do in the real exam. You should rinse your pipette, take a little bit out, suck a little bit out of the solution that you need to fill the pipette in, and wash it, and then, before you start titration. Similarly with the burette, if you're in a real exam, you don't wash your burette with distilled water, you can just rinse it with the solution that you're going to fill it in. Rinsing is not filling it up all the way up and throwing it away. Rinsing is probably just filling it up, a little bit like 10 cm cube, and then you roll it around and then you throw away the washing. And that way, at least you remove impurities. Another way is you fill it in with the right concentration of the stuff that you're going to fill it in. So I'm just going to wash my conical flask with a little bit of distilled water. Now these are conical flasks that I'm going to, pipette my stuff out into. You see my conical flask has a bit of water left in there. It really doesn't matter that your conical flask is a little bit wet, because the mole that you pipette out, if you pipette out 25 ml or 25 cm cube, that is going to be exact mole of the substance. When you put it in there, all the mole goes in here. A little bit of water will change its concentration, but what you put in is 25 ml, and what you calculate will be for the 25 ml. The amount that you put in will still be the same, and therefore it will not affect your burette title. Okay? But in any regards, I try to keep it as dry as possible, but a little bit of water left in there is not a big issue at all. So I'm just going to rinse that. And I'm just going to turn the camera around how we are going to rinse the pipette and burette. So I'm not too sure if you can see this, but I'm passing some water through it. So I don't know who was the last person to use it. I need to really roll it around. So I just roll the distilled water around the thing there, and then I just let it go away. But remember, we have distilled water left in here. We need to ensure that it is rinsed with the solution that we need to pipette out later on before we use it for the very first time. Similarly with the burette, I'm just going to pass some distilled water through it. So this is just washing. I let it run through, and then I just open the tap so that all the washings go away. Again, you need to rinse this with the solution that you're going to fill in the burette later on. So this thing doesn't take too long, but you need to allocate enough time for you to do the actual practical. So in this experiment, we will have to put this solution. This is P and this is Q. I have to put P, which is sodium hydroxide, where I have to pipette it out, and Q goes in the burette. Q is the sulfuric acid. So if Q is the sulfuric acid that is going to go into the burette, what I'm going to do is I need to make sure it's closed. I put a little bit of Q in there, just a little bit of Q in there. Not all the way up there, but just so it fills a little bit because I am doing washing. So if I am doing washing, then I will just open the tap and make sure it washes down to the bottom, close the tap, and then roll it around so that I am washing the top bit on the side as well. Don't forget, these are your washing there, so you have to open the tap and let it run through. Okay, do not wash with distilled water again. At least now this is rinsed through and this has been washed with the solution Q here. But remember, this is now closed. When I fill it all the way up there, do remember that you need to open it up again. So I'm just going to fill my stuff all the way. Typically, teachers in school will tell you to start from 0.0 cm3, but it's always my opinion that you don't really have to start from 0.0. You will realize that this reads, well, somewhere just above 0, but then I haven't opened my tab. Number one mistake. Open your tab and let it run through because you need to fill this thing at the bottom there. So when I read this now, this thing is not exactly 0.0, but I know I can start from any volume. But to make my life easy, I'll probably just start from 2. So I'm just going to run this through. Okay. So a bit of hand-eye coordination. Hopefully you can see that that is 2 milliliter or 2 cm3. It's easier if I have a screen behind me. Don't forget, this is 2, this is 3, so you read downwards. You read below the meniscus. So you already read it. I'm just going to put it there. So there's 2.0 cm3 there. 2.0 cm3. And I'm going to have to wash my pipette. Hang on, let me just move this around. I have to wash my pipette with the other solution. So P is what I pipette out. So that is the sulfuric acid. Sorry, that is the sodium hydroxide. This is what you call a pipette filler. There is the A button there. So when you press it and then you squeeze it, all right. And then there's the S button there that will allow us to, suck out the solution. But I just want to do some washing, so I just suck out a little bit. Just suck out a little bit, and that should be enough. And then what I do is, I go to the sink here, and I just take out my stuff there, and I want to roll it around and wash it. Okay, and then I let everything go, because that is just washing. Okay, so all that is done, and now we are ready to actually perform our first titrations. So I don't know how long that has taken, but without explaining to someone, it probably take you a bit shorter time. I find it that if I do it at an angle, it sucks a bit better. So you suck out a bit more than what you need. So you will see that the line is there, but I've sucked out more than what I need. So what I'll do is I will just remove the excess one. I'm just pressing the E button to eject. Okay, so I'll just show you what I've got here. So you see this is the burette reading. This is the pipette reading. So just above, you read just below the meniscus. That one is 25.0 cm3 because this is a 25 ml pipette. So when you just get to that level, there's 25.0 cm3 there. What we do next is we just go all the way, and it doesn't matter if it is a little bit wet, as I mentioned, because you have 25.0 cm3. You press E, and then you slowly twist it around, and then you release the pipette filler, and then you let gravity does its job. Just let gravity does its job. Don't do tapping, don't do whatever. Just let gravity does its job, and it will go into the conical flask. Okay, it's the last few drops that gravity might not be able to do its job. So what you do is you tilt sideways, and you tap very gently because glass and glass. 1, 2, 3, 4, 5. That should be enough. There will always be a little bit of stuff left behind. It's already taken into account by the level of accuracy in the pipette. So I'm going to do my rough titration. My burette just now read, this thing is a bit sideways because the retort stand is not very good. So that is now 2.3 cm cubed. Just now it was supposed to be 2, but somehow it's gone to 2.3. Don't know if it is leaking. If your stuff is leaking, you need to let someone know. I'm just going to make my life easy and go to 3. I think there's 3 there. So how you read the burette? Well, you need to read it in such a way that it is 1 decimal place. It's required by all level IGCSE or GCSE level standard. But then in A level, you record it to 2 decimal place. There's something that A level students would know anyway. Okay, so that's 3.0 cm cubed. And let's get started on our titration. The very first mistake the student do is they try to do exact titration from the very first one. And you shouldn't waste your time to do exact titration from the very first one. You should be looking at rough titration. So let's just lift this up. I need it to be there. It's not a very good stand actually. I put a white tile there so that I could contrast the color there. This is colorless and this is colorless. It won't produce a color on its own when it reaches the endpoint. I am using an indicator. This is called methyl orange. What I've got in here, well, let's see. This is orange. When I put that in there, I get like a yellow solution. This is a yellowy solution, and that is because it is in alkaline solution. What I prepared out was from P, and that was NaOH. I started from 3.0. Okay, so when I'm doing rough titrations, I don't care about the volume there. I know what I started with, 3.0 in the burette, 3.0 in the burette, initial volume. Just let it run and notice the color change. Let me just zoom in. Notice the color change. I should have swirled it around. So I'm doing a rough titration, so it will be in excess. And when it is in excess, I don't really care how much in excess because it will be in excess regardless. So I will stop when there's color change. I will stop when there's color change. Not too sure how clear this will be reflected in the tutorial video, but let me just try my best. So not too sure how clear the color will be, but I'm looking down the white tile, so I'm pretty sure it hasn't reached the endpoint yet. So it's slowly turning there, slowly getting there. I think there is more orangey. So this is probably it just reaching the end point just now, okay? But of course we are not trying to be exact here, we're just doing a rough titration. I'm just going to add a bit more. And still a bit orangey. It's hard to tell whether this is orange or pink, yeah, okay? Not too sure how clear the color will reflect. It's let me just read the reading first. Just now was 3.0, now it is 26.7 minus 23.0, so that is 23.7. 23.7 should be in excess already. 23.7 is in excess. I'm just going to add a lot more and see what happens. Yeah, there's no more color change. That was definitely in excess. So 23.7 cm cubed was definitely in excess. And when that is in excess, we need to be aware of what volume we need later on in order to go and be exact. 23.7 is rough tighter. It was meant to be in excess. I wasn't careful there. From my second titration onwards, I must be very careful. Alright? So I'm just going to top up my burettes because you don't usually start your titration from a volume this low, around 27 point something. So Q goes in the burette just now. So Q is sulfuric acid. So that goes in the burette. I do not necessarily have to go all the way to 0.0. Then I will need to Okay, so this is now 10.00. So that's 10.0 for 1 decimal place. I'm going to start from 10.0. We said that just now 23.7 was in excess. So give or take 23.7 plus 10.0. So started from 10.0. So 23.7 plus 10.0 will give me 33.7, but that is in excess, so I will slow down when I reach 30, and then it should be safe enough. Alright, I'm just going to pipette out my stuff. So I need to try to be exact from the second one onward, yeah? And then I'll do the third one, which is super exact. So I'm pipetting out 25 ml, 25 cm cube. So you could see my, is this accurate? Yeah, that is pretty accurate, I guess. So that one is just 25 cm cube there. So I put it in my conical flask, press the E button, while I also twist my pipette filler around and let gravity does its job. So I'm starting from 10.0 on my burette, and I will slow down around 30 because we know it was 23.7 for rough titration, that was in excess, so we need to slow down and not be greedy because you don't have much time in the real exam. Okay, so towards the end, we just let gravity do its job, and then 1, 2, 3, 4, 5, that should do its job. Put a little bit of indicator, 1, 2, 3, 4, 5. So it's yellow, it is different actually. So this is an alkaline solution, yellow, and it is in excess acid, and it goes a bit pink. We want orange somewhere in between. If you can't tell the color difference, you can add a little bit more. Ideally, if this is yellow, this is the orange color that you should go to when you reach the end point. Okay? So I'm starting from 10.0, so I will stop and be careful from 30.0 because it was 23.7. 23.7 plus 10 is 33.7, but I will slow down when I reach 30.0. Okay? So I will just go full speed. This thing is not working out that well though. Not too sure why. Oh no! I think the burette is messed up. Hello again. So we had a bit of an issue where the burette was leaking, but I kind of fixed that, so that is now 10.0 again after I top it up, and I'm going to try again. So this is actually a good idea of what happened when you're given 2 conical flasks, and then both your flasks you have to reuse them. So what you do is you just chuck them away into the sink, and you wash with tap water first. Chuck it into the sink, wash with tap water. So this contains tap water. You just want it as dry as possible. Then don't forget, rinse it with distilled water because tap water might contain some other impurities, but you don't wash the thing with distilled water from the very beginning. It's actually a waste of distilled water. So try wash with tap water first, and then only before you use it, you kind of rinse it with distilled water again. So they are meant to be wet because the moment you use them, you wash them, you can't get rid of all the water inside until they're dry. It's okay. As what I said earlier, the amount of water in here will not affect the mole of what you pipette out. So we're gonna have to pipette out the sodium hydroxide again. So there was P. So using a pipette, you should know already. P is the sodium hydroxide. So in an exam, when you're rushing through, you want to avoid mistake, but you don't have much time to try and do things really slowly because time is very, very important in the real thing. Okay, so that one is 25.0 cm cube on the pipette. We want to try and do 2 exact titration, so what I'll do is I'll just pipette out 2 conical flasks straight away. So I already done 1 rough titration, and obviously we need at least 2 exact titrations that are as close to each other as possible. within an acceptable margin of error. So I prepared out my second portion of the solution P. Very important that you don't mix up your chemicals. That happens, well, that could happen, and when that happens, it will be very bad for you. Okay, so I think I might have a little bit of air bubble inside, but anyway, let me see if I can get rid of it. I reckon that one. Oops, no, that is not good. That is actually not good. So let's check. The air bubble is never good. And then I will start with more out. Is that better? Could be. As good as it could be, I think. Am I correct? Yep, as good as it could be. So there's 25.0 cm cube there. Gonna put it into the clean conical flask. Let gravity does its job. So don't know how long this 2-exact titration will take me. Hopefully the burette doesn't give me any more issue. We just let gravity does its job. Only towards the end we do the tapping. So don't do the tapping from the very beginning, yeah? Okay, so it seems like gravity already did most of the job. 1, 2, 3, 4, 5. Add a bit of indicator. Some students thought, how come you can't see any color change? Because you haven't added any indicator. When you're doing acid-base titration, it's colorless. This is yellow because this is sodium hydroxide. So methyl orange is yellow when it is in base, when it is in sodium hydroxide or any kind of hydroxide. It's gonna go orange when it reaches the end point. It's gonna go pink or kind of reddish actually when it goes to being in excess acid. All right, so let's just get started with these titrations. I need to double check my initial volume. So there is 10 point, not too sure if you can read properly, but there is 10.0 cm cube. So you will fill in your table as you go along. Yeah? My rough titration was around 23.7, so 10.0 plus 23.7 should be 33.7. But I don't want to stop there because there's in excess. I will slow down around 30 cm cube. So I will let it flow until it reaches 30 cm cube. Okay. So 30 cm cube is around here. So I let it go, free flow. I don't even have to swirl it or anything until it reaches 30 cm cube. That is way before it is in excess. Then I will do it drop by drop. Okay. So it's getting there. It's still there. It's going down, down, down. So we know it won't be in excess because we were being calculative. When it reached 30, that is when I will start to do it drop by drop from there and try to be exact from my second titration onwards. Right? So you might see that this thing has gone a little bit pink here. Let me just show you. So I haven't swirled it or anything. Okay, I haven't swirled it. But then when I swirl it, the pink color is gone because all you have left there is not excess acid. You still have excess of this hydroxide in there. That's why it's still yellow. Okay, so let's just focus on that. So technically speaking, I should be standing up when I'm doing this, but it's a bit tricky. All right, so I want this to be a bit there. So my eyes are no longer on the burette. I just need to get it drop by drop. This is the most difficult thing, I guess. Get it drop by drop first. Okay, so that is drop by drop. And it won't be in excess yet. Once it is drop by drop, then you swirl. Then you swirl gently. Let me just zoom in on the color change. Hopefully you should see the color change. So this is the slow bit. Okay, you need to rush the other bit, and you don't waste too much time doing 1000 titration. You do one rough, and then you try and to be exact from the second one onward. Your hand is always on the tab here because once the color changes to orange, then you stop. So at the moment it is still yellow, and when it turns orange, I think it has just turned orange actually. So this is yellow, this is before. Not too sure how clear it is, but this is yellow before any acid. There is orange at the end point. Perhaps I could just read the reading first, and if I'm not sure, I can always go and add one more drop. So my reading here is 32.8. 32.8. All right, 32.8. Maybe I need to lift this up a little bit. 32.8 minus 10.0, that means it's 22.8. Okay, so that's my exact titer number 1. But you might think, what if I add one more drop? Before you add one more drop, you should read the reading first, okay? So notice the color. I already saw it changes because it's easier on the eye than perhaps with the video camera on the video. So I'm just going to add one more drop and see what happens. So it's pretty much still the same color, but of course if I add more and more, it's going to go beyond the yellow, orange, it's going to go to the pink. But the moment when it changes color, there's a sharp end point. You shouldn't be too far from my exact titer if you're my students, because your result will be marked based on your teacher's result. So make sure you check with the teacher, right? So that is still around 22.9, 22.8, because I already taken the difference, yeah? I'm just going to add a couple more drop and see what happened, because I already took note of 22.8 as my best titer. You will see that the color has gone pink now. So just now was orange and now it has gone red. Sorry, it's a bit light, so it looks a bit pinkish, but it's actually gone a bit more red. I could add a lot more and you will see no further color change because there was already in excess acid. Alright, so I'm just going to top up this thing. We're already quite exact just now, doing it drop by drop, doing it really slowly. So Q is the sulfuric acid. That's going to go into the burette. So we know roughly it's around 22.8 being exact. So if I start from around 10, that will make my life easy. Hang on, let me just get this done properly. Nope, I need to top out a little bit more. So there's 10.00, well 10.0 for O-level, GCSE or IGCSE level chemistry. So there's 10.0 again. And we expect to be 22.8 based on our first accurate titer. So 22.8 plus 10.0 is 32.8. So this time I don't need to slow down at 30, I can slow down at 32 because you know 32.8 is going to be 22.8 plus 10, which was my initial volume just now. So 32.8, so I should slow down maybe around 32. Then I'll do drop by drop just to be exact, because we know we are getting closer to the end titer now. We could do this because we roughly know where we are fishing out the titer. So I'm gonna wait until it goes to 32, so then I will stop. So now it is at 32. So now the burette volume is at 32. Not too sure how well you can read that, because there's 33, there's 32.0. And we know there's not endpoint yet. Not the endpoint yet. You see that this goes a bit like yellowy stuff. Well, I mean, orangey, kind of reddish. But now it's gone back to yellow because, you know, there's still not the endpoint yet. Now I'm going to do drop by drop. We need to be very careful here because I'm very, very close to the endpoint, so I cannot overshoot this. Otherwise, I'll be wasting my time. I need to go slow and get it right. Go slow and get it right. Okay, hang on, not yet. Yep, so that is drop by drop. My eye is just focused on the color change. When you go from yellow all the way to orange, that is when I stop. There you go. It just turned orange. So it was just yellow a while ago and it's gone orange. And I can confirm that I have got 32.8. So that is 32.8. So I'm reading at an angle a little bit because the camera is, the video cam is kind of like slanted downwards. But if I just move this up to horizontal level, that means you should be able to read this as 32.8. Make sure that when you read burette reading, you can see it's 32 on top there and then 33 at the bottom. So that's 32.8. Minus 10.0, this gives me the 32.8. This is in excess. This is just at the end point because it was yellow to begin with when you were in alkaline condition to begin with. You were yellow, then you go to orange at the end point, Then you go to reddish when it is in excess acid. There's the color of metal orange in those conditions. Okay, so I think that's it really. So I've done one rough titration. I know roughly where it is. Then I can slow down, minus 3 cm3. I slow down and do drop by drop to get my second exact titer. Sorry, my second titration, which is my first exact titer, because my first titer was a rough titration. And then I repeated the third titration, which is my second exact titer, knowing my first exact titer was super exact already. I'm not wasting a lot of time. I do drop by drop when I'm really close to the end point, because I added my first accurate titer with the initial volume. I know roughly where to stop, and from there I know where my second exact titer should be roughly. And without caring about the volume, I just look at that. When there's color change, I stop, I record the volume, and it was still 32.8 minus 10.0, which gives me 22.8 for this titration, which I did from this batch of solution with my own students. Of course, when your teacher make out your solution, your result can change, but the technique will never change. The calculations involved will never change as well. Alright, thank you for watching. Don't forget to click the button on the bottom right throughout the videos on my channel to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry. On Facebook, Instagram, Twitter, and Telegram to get connected. Across all my videos, there should be in the video description a link to a master Google document, and inside there you can find all the various playlists that can help you all your IGCSE, your GCSE level chemistry, as well as A level and IB level for the 16 to 18 years old curriculum. Thank you for watching. I'll see you in the next tutorial video.